so great to see you. Thanks for being here. Yay.
Oh, thank you for having me.
Yeah, it's going to be fun, I think. I want to introduce you because we have this problem where we start talking because we get excited and we don't introduce people. So I want to introduce you right now. So this is Neil Theise. And did I mess up your name?
No, no, no.
I got it right.
Yeah.
I call you
Glad
Neil.
you said it first.
Yeah, I know. I think in my mind I still wonder. Um, I just call you Neil usually. So Neil has been very kind because he's a friend of mine to come on this show, even though he's also a bigwig in the world of science and especially new discoveries in science. He actually discovered a human organ that had not been discovered before.
Oh,
Hello.
wow.
And also is an expert in complexity. And by expert, I mean um, exactly the opposite of that, because of course complexity requires that there are no experts in this particular field. And welcome to Pandas Playing Cello.
Thank you so much.
Oh, I forgot to say, also you have the part of why we know each other is you have this amazing relationship with spirituality and inner wisdom and consciousness. And that's
I
also
do.
it turns out you do. And that's also a piece of who you are. And so that, of course, that's something that's interesting to us as well. So I think, or at least me, and I know also Carmen. So
I will tell you, Neil,
yeah.
if I may call you Neil,
Of course
that
you may.
I heard about your book weeks before Julia ever mentioned you. I got an email from a former colleague of mine, Jay Oki, and he goes, I just read a great book that I think would interest you, and it's short and it's,
Short
yeah,
with pictures.
yeah, and etc. And then it was your book.
Wow.
So
It's the word of mouth is keeping it aloft in a huge way, which kind of also blows me away. You do these sorts of things, not that I've done it before. And you don't know what you have, and you don't know how people respond. And it just story after story of someone telling someone, people handing it out to their families as holiday gifts,
So
yeah,
the name
it's
of the
very
book,
interesting.
is
Notes on
Notes on
Complexity,
Complexity.
a scientific theory of connection, consciousness, and being.
excellent. Thank you.
Took
Gotta
me a
say
while
it.
to learn it.
Yeah, right. I know. And also, I'm sure, like, as a scientist, I experience the same thing is that you forget to plug your book when you're doing these things because you get
I'm not
involved.
very comfortable.
Yeah.
And I feel to some extent, I mean, there's part of me that like, it's my book. See, I have the Chinese and the English edition right there to prove to myself it's my book. But there's a big piece I'm learning of, oh, it's not mine anymore.
Yeah. No.
It's out there and it's
Right.
a thing, and I have no idea where it's headed or what the repercussions will be, etc. Which is kind of like, complexity theory.
Yeah.
Now,
Exactly.
how long, I'm going to ask you a really booky question.
Sure.
How long did it take you to write it? Was it something that you wrote bits and pieces of it down in journals or,
Oh no, I
for
don't.
example, and then were able
Yeah.
to build on that? Or was it really just something you decided to do as a project?
Neither. I've been talking about this material for 20 years, 22 years. I discuss in the author's note at the beginning how I was introduced to complexity theory by an artist named Jane Prophet when I was sort of doing my first science that went viral, which is, I don't think we had things going viral, but this was back in 1999, 2000. I was doing stem cell research, and because of the notoriety of what I was doing, I wound up in this art science interdisciplinary thing where people from the Wellcome Trust, on the suggestion of a mutual friend of ours, were putting scientists and artists together just to see how they might communicate. And we didn't have to come up with any projects or any reports. We just had to record our conversations. And so that was with Jane Prophet. And our mutual friend, Peter Ride, was a curator of these kind of things. And in the course of me telling her about how we were coming to understand how cells move around the body and how stem cells can move around the body, which was novel 25 years ago, she said, oh, that's like how complexity theory people talk about how slime molds behave and how ant colonies form. And I was like, what's complexity theory? So she started explaining it to me. And then talking to her, we expanded the team a little bit to bring in a computer modeler and a mathematician. And we started just exploring it regarding stem cells. But the moment you dip into complexity, if you're open and paying attention, it just leads you to everything. So within a couple of years, including Buddhist metaphysics, which was my first spiritual stop with the complexity stuff, and I gave my first talk on complexity and stem cells and science and Buddhism in 2003 at the Village Zendo, which is my home for Zen practice, because it's a very smart group of people and it's a great place to try out new things, regardless of what the topic is for me. And then it's just grown since then as I continue to present it, people asking me to talk about this stuff, and then through presenting it, meeting people. Eventually, it led me to I think it was 2010, there was a meeting of the annual meeting, what used to be called Towards the Science of Consciousness. Stuart Hameroff, who's Roger Penrose's collaborator in consciousness studies, they were hosting the meeting in Stockholm that year. And a friend of mine was invited to present, Bill Bichelle. Have I introduced you to Bill, Julia?
No, yeah, I've always wanted to meet him, but I
Yeah.
also I think we didn't. I keep thinking we met at that meeting, but I think we met at Science and
Yeah,
Non-Duality.
no, we met at Sand, yeah.
Yeah,
Or Ions, I'm not sure which came first either. I think
yeah,
Sand. I think it
yeah.
was
I
Sand.
think Sand.
Yeah, but so sorry, long story short. He was presenting, but he wasn't very comfortable back in those days presenting in front of of an audience, and asked me to go in support of him. I was just like, but I don't have anything to say. So I pulled together a consciousness thing that, looking back, I realized, oh, this was a panpsychist approach to complexity theory, consciousness in the universe. I wrote an abstract. They accepted it for presentation at this tiny little side thing where there were going to be 3 things presented, 3 or 4, with an audience of like the people presenting and a few of their friends.
That's exactly.
Yeah. And in the morning, I went to a plenary session on quantum physics and consciousness, and it was this guy, Menas Kafatos, presenting, and he was elaborating towards the end of his talk on the reason we don't understand consciousness is that quantum physics isn't enough. We need a new kind of biology to explain consciousness. And the more he described what that new biology would look like, I got angry and left the room, because it's like, this is the complexity stuff I'm writing about. No one's paying attention to me. I've got that new biology. And I stormed out.
And you were probably red-faced, Neil, if I know you.
Yeah. And that afternoon I go present my thing, and it turns out he's the moderator for the session. And I present my stuff, and he leaps after I was the last one of the afternoon, and he leaps on me. Here's my card. We have to talk. Without me even saying to him, oh, I think he just saw it. And then we started collaborating, and that was what led me to the final path into really how to understand complexity, how to tie it together with Buddhist practice, Jewish mystical practice, in his case, Advaita Vedanta, and Kashmiri Shaivism. And so the talk kept growing. This is what I was saying. I would meet people and things would extend and extend. I didn't want to, so we've written academic papers on it. But I never wanted to write the book because I thought it would have to be 400 or 500 pages of densely annotated. And I'm not, by training, a complexity theorist. Who am I to do this? I wanted to write a book about my mom's last years. She had a remarkable last 8 years where she lost her short-term memory and started talking to dead people, and spirit guides from the universe started showing up, and she ended her days in a total bliss bubble.
Wow.
Yeah, at home
Wow.
and smiling, thrilled to like, she was done. And so I wanted to write that book, and I got an agent, thought that was a good idea. We pitched it to a lot of publishers. We got a lot of high-level interest, but their response was, sounds like a great book. The writing samples looks like he can write, but why would we want to know about this guy and his mother? And one of those editors went online and Googled me and saw my talks on complexity. And he said, oh, this is why we'd want to hear about this guy and his mother. He has to write that book first. And I said, no, 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 no. And my agent said, she sent me 7 brief lessons in physics by
I know that.
Ravelli,
Yes.
which was a very thin bestseller, quantum physics. She said, you can write your talk as a book this scale. And then we shopped it around and got lots of high-level interest. So now we're on year 4 of trying to write a book. And all these editors, everyone was telling me, you're going to auction, you're going to auction. It was very exciting. And then every single marketing division said, we don't know how to market a book like this. It crosses between too many different topics. And it got rejected by everybody. But then my agent...
So if I may, it was rejected because of the complexity associated
Yeah, I mean, this is so
with marketing
perfect.
something
Yeah.
about complexity.
Yeah, yeah. And it's high-level news. I mean, in part, there was an antitrust trial with in the US, Penguin
Yes.
Random House wanting to then combine with Simon and Schuster. And one of their points is decisions are now being made by the marketers. It
Yeah.
should be made by the editors.
Yeah.
When Penguin and Random House merged, one of Random House's primary well-known and respected imprints, Spiegel and Grau, Cindy Spiegel and Julie Grau are the editors. They were founders of Riverhead Press back in the day, and now they were this remarkably successful imprint. They were tossed out. They were closed down because of the merger. And so right around the time that happened, shortly before my book got rejected, they decided to start their own publishing house independently that winter. And my agent knew one of the new editors they hired to start. And they pitched. It was a remarkable afternoon because we were meeting, it was COVID, we were meeting online. And the editor, Cindy and Julie, a couple of other people from their side, me and my agent. And my agent, I'd never done this before. She prepped me all day and said, they're not going to accept your book.
Oh,
They've only
good.
found
Oh,
one.
thank God. She
Yeah.
knew how to work with you.
No, well, but I think she believed it. She said it's a brand new house. They're looking for things that will define them.
Right.
They've only signed one
Oh,
book.
sure. What are the chances?
Yeah, what are the chances your book will be the second book they find? They get online, the Zoom screen, and Julie is sitting in a corporate lobby that vaguely looks familiar to me, wearing a mask, and says, I'm really sorry I'm not in my home office and have to be wearing a mask, but I'm at NYU Langone Hospital. My mother's upstairs in the intensive care unit. And I said, I'm 4 floors up. That's my hospital. Presented it. They were selling me on why I should want to give my book to a brand new startup.
Oh.
They clearly wanted it. And then after the call, I went downstairs and I spent the next 2 weeks helping her and her sisters cope with, because I know about elder care with mothers. That's the other book. And so that's how it came to be. Then we started writing it, and at first I thought, oh,
Wait, we started writing it, so you have a co-author?
no.
Is that the royal we?
My team.
Yeah, yeah. Got it.
Because I learned that you know, books do not spring from your forehead fully formed.
Yeah, so you
Like
had developmental
Athena,
editors. Yeah.
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 And
Wait, Carmen, what did you say? I missed that.
like Athena. That's one of my
Yes.
favorite
that was my reference. Yes.
Yes.
literary allusions and metaphors about. I'll just interject this here about
Please.
how when you're trying to change, you want to present new ideas, you're trapped in what I call the Athena complex,
Right.
where people expect your idea to be perfect and fully formed, or they won't even consider it, which
Yeah.
is nuts.
Yeah.
Writing a proposal for a book. I haven't
Yes.
written the book.
Yeah,
I
right.
didn't write the proposal when I
Right.
wrote the book. But
Yeah.
no, I can't write the book until I write the proposal.
We
No,
we need to just generally, I think this is a really important point to just stop and mention, and I think this also relates to complexity and spiritual development. Generally, we sort of don't appreciate the developmental path of anything. People,
yeah,
like, oh, people can change and grow, and that's important throughout your life. Or, oh, this book can start in a little seed and grow into a flower. Like,
right.
I,
And you thought it was about this, but it turns out to be about that.
well, right, exactly. And
Yeah.
what emerges is something different, and that's all
Yeah.
part of the developmental cycle. And it's so interesting to me because, of course, now in the era of AI, we sure need to understand the complexity of the developmental cycle, right?
Yeah. Yeah.
Because
Yeah.
the concerns and bets about what will emerge. Anyway, just seeding the conversation for future
Yeah.
directions.
Sure. So what happened was I started working with this particular editor. It turns out retrospectively it was not a good match, but didn't know. I was a first-time author. Um, this editor is kind of a boy genius. I did whatever he said. It turns out when I finally handed in the book a year and a half later, it was sort of like first I wrote this, and then it was suggested that I write that, and then let's stir this in, and then who told you to do that part? You did. Oh, that doesn't make any sense. So it was a bit of a fraught process, and then I handed in the book, and my agent and Julie, my publisher, said, "This isn't the book we thought you were writing." And I said, "It's the book I was guided to write." And then there were some odd circumstances, and we were in copy editing week. And my first editor sort of crashed and burned with some health stuff. And Julie had to step in because we were already late, and it was copy editing week, and I didn't know how to copy edit. And the moment we started talking, it became clear what the book needed, and we rewrote the book in 9 days.
Oh my God. That's such a
Um,
great story.
so it was, you know, I think there is no process to writing a book. There's what you think is your process, and it'll probably be different the next time. There's what you hope the process will be, and it's never that. And I think my Zen practice to some extent has helped cultivate an ability to pivot. If it's really clear that the true nature of reality is this, when you thought it was this, don't try and hang on to this, just go with the new. And the new was, I had a new editor in front of me, and I said, I think I need to chop like 40% of this out. And she said, have at it. And most of the editing was just eliminating things and then smoothing over. And but with that, you can imagine my insecurity about what the hell have I written?
Yeah.
The last feedback I got was, this isn't the book we thought you were writing.
Well, but what about you? I mean, how would you summarize what
I,
you've written versus what you thought you were going to write versus what other people say it is? I mean, those are sort of three takes on it.
I think right now it has actually become what my talks were. I thought initially I could just sort of transcribe the talk and fill it out a bit. And I learned that the way I tell stories when I'm speaking is not the way one tells stories when you're writing. And so the style of presentation had to be very different. Um, how much you have to unpack every single thing in a 45-minute talk. I can fly by something like, well, there's the double slit experiment. And there's someone in every audience who understands everything that I say, but there's no one in every audience who understands everything. themselves. But that's okay in a talk because you're on to the next thing. In a book, and then just real simple, my first editor taught me this, is that if you have a poorly written sentence, if I'm reading a book and there's a poorly written sentence that I have to scratch my head on, like, let me read that again, that's okay once. If it happens a second time, pretty much, certainly a third time, I put the book down. So just the fact that there can't be any speed bumps in your language that take the person out, learning that is so nitty-gritty fundamental, but I really had to learn how to recognize that. And all the standard things, my husband, who used to be a playwright, he was like, you have to read it aloud. And I was like, I can't read this aloud to myself. And he was like, you have to do it. I made him go out of town for a weekend because I wasn't going to do it in front of anybody. And the moment I read it aloud, it was like, third page, there was a paragraph. Only then did I notice that it was a whole paragraph with no periods. Or that the rhythm, in my head, the rhythm was great.
Yeah.
The moment I read it aloud, it was like, that's terrible. Things like that.
Well, you're
I'm
speaking
sorry?
to
No. Sorry.
you're speaking to one of my favorite topics. So my career is as a, kind of a hack. I wrote for the CIA, so I was a hack, but in the sense that I wasn't writing great literary prose, but it was very difficult to persuade people that if a policymaker who only has 5 minutes to read your prose stumbles over one sentence, that's it. You've
That's it. You've lost
them.
them. Yeah.
You've lost them.
See, and in a lifetime, in an adulthood of writing science papers, it doesn't matter how well written it is. People know what information they want to get. So they go to the abstract, they look at the figures, they read the legends, they read the introduction and the confusion.
Yes,
That is
that's usually what it
fantastic.
is.
The conclusion.
That is fantastic.
And I've never made that slip before.
That's a great
Um,
one.
But they'll
Now
overlook,
for the confusion.
yeah. And people tell me I write readable papers. People have told me some of them have been downright elegant, but now I look at them and go,
Yeah.
not if you buy a book for your pleasure, you don't need to get something because professionally you need to know what the latest thing is. It's a whole other story. So, and what I had been guided to write, my first editor kept having ambitions for what the book could be. So his first primary interest in the book, I think, is that no one has written a book on complexity theory that had really culturally become a thing, the way, in particular, James Glick's book on chaos theory did 20 years ago. So he thought, I think, that he was getting the next James Glick writing about complexity. And I'm not him. I'm not a science writer. The next thing is, once it became clear what I wanted to be writing and should be writing, which was what I'd been doing for the prior 20 years, the opening was 3 chapters of, well, I have to explain the history of science that brought us to complexity. You don't need 3 chapters for that. And it's sort of like, why am I reading this? There was a nugget of what became the opening somewhere in the middle of that. But so that was the first chopping block. And, Einstein and relativity. And, I mean, I was talking about Poincaré and Einstein's mathematics, and
You were
then
trying to do the Glick thing.
yeah. Though even Glick would have known better than to go back over everything
Way
in
over,
detail. And then there was a feeling in the later part of the book where I talk about Kurt Gödel and his incompleteness theorems. He's such a fascinating person, thinker. And again, he hasn't entered the popular imagination. So then my editor got all excited about how this book could be the one that brought Gödel to the popular imagination. So there was this history book, and I'm not a historian. There was this almost complete biography of Gödel, and I'm not a biographer. And then there was my stuff somewhere in there. So that's what it became. And then with Julie, she gave me the courage to just go, no, this belongs, this doesn't. And I have no ego about my writing. It's like I can, and there was in the Gödel section, pardon me, I'm going to have to blow my nose here. Pardon me, turning around.
Oh, we get to see the top
I
of your
love
tattoo.
Girdle. I
Oh,
love
my new
him.
tattoo.
Yeah, yeah. So that looks like a butterfly and also like a Zen symbol, yeah?
It's actually a medieval magic spell reduced down into a sigil. And I can't tell you what the magic spell is.
Of course it wouldn't work.
So,
Wait, Carmen was saying she loved Girdle. I was saying I loved your tattoo. The tattoo won.
I love Gödel too. Way more than I used to love Einstein. Gödel and Bohr are now my heroes of scientific and clarity of thought. But I didn't eat as much of him as was in there. And what was I saying before my nose?
Oh, because you ended up feeling free and having no ego about your writing and
Oh,
slashing and burning
So
your
the idea
stuff.
of, yeah, I was writing the Gödel stuff, and when I chopped out, I'd say 70% of what I had written about him, in the middle of that, there was one great sentence. And I realized I would never have gotten that sentence if I hadn't written all of that. So I'm working on my mom's book now. I'm on to the book I wanted to write. And I'm loving it because I'm just hurling mud onto the board, and we'll find the pot later on. And I just now know to trust, pour it all out, and you'll find the things you need. And compared to a life of science writing, oh my God, that's just such pleasure. So I think the next book, I'm probably wrong. I think the next book will be less fraught than this last one. Or at least I'll be more relaxed when I have to respond to its stresses.
Hey, Neil,
Yeah.
your comment about the freedom of writing non-science stuff, I relate to. I'm working on a
Oh,
fiction
I'm
book.
sure you do.
And when I get into my science frame, I realize the frame is so different from my non-science frame.
Oh,
And I wanted to sort of ask you to put your finger on that, because for me, the distinction is about what I'm imagining the audience is thinking
yeah.
and the constraints that puts on me. But do you have a different distinction, or how do you distinguish those things?
Yeah, there's an issue of audience expectation. Scientists expect a certain kind of documentation. I know how to write without letting the need for references get in my way. Everyone has their way of coping with that little bit. But there's also, well, in this particular case, this came to me actually just like 3 or 4 days ago. And I've been thinking about this book for 5 years, right? But I'm just finding out what it is. First, I thought it was going to be a book about elder care with a few of my mom's interesting spiritual, magical stuff happening in the middle. Then I wrote Notes on Complexity and realized, no, my mother's book is about that stuff. The stuff I couldn't put in Notes on Complexity because I had to get it past a certain level of scientific rigor. Now, there are people who hate this book. And hate me to some extent. My reviews on Goodreads are very entertaining. I think my favorite line is, this book makes Jonathan Livingston's Seagull seem like a spiritual text. And so, are you old enough to know, Julia, who Jonathan
Yes.
Livingston? Okay.
Oh, absolutely. Loved it.
Okay. But I still have a 4.1 rating, so the majority of people are fine. But so that's how I was thinking about my mom's book, but I was still thinking about, I do have ways scientifically to try and understand. I have some hypotheses about what are non-material planes of existence, the astral plane. what and who are non-material living conscious beings that we can encounter? How do they fit into this model of the universe that I describe in the first book? So I thought, oh, that's what the book is. And then just before her maternity leave, my agent, who she's always been I've learned whatever she says, just listen. I'm really lucky. Amanda Annis, she's just spot on with everything. We had this last chat before she disappeared into paternity leave for 3 months. And suddenly this new sort of forward author's note came to mind. Oh, this isn't about what follows Notes on Complexity. This is the memoir about my spiritual life that set me up to encounter the science that became Notes on Complexity. But this is the stuff that came before. And if I put some science in, well, that's who I am. Of course, I'm going to put that in there. But if people are going to say, oh, I don't believe this stuff, well, that's like saying, I don't believe your dreams.
Right.
The dreams are mine. They're my experiences, and they have meaning for me. That's all you need to know. They don't have to have meaning for you. But I'm telling you, they have meaning for me, and this is what the meanings are. And I think there are a lot of people who are going to read this story and go, oh, thank you. I've had experiences like that, and I'm afraid to talk about them, but they do have meaning for me too. Dead relatives who appear to me after they die, or beings who come to me in dream time, or. And so that's really freaked me up, that I don't care what a scientific materialist thinks. I'm not even writing this for anyone who cares about science. Notes on Complexity was clearly a scientifically minded audience who's interested in more open perspectives about consciousness, about the nature of reality, metaphysics, blah, blah, blah. So that had to be a certain structured argument. This is just me and my mom and the weird shit presented itself to us, mostly to her. So that's
Wait to read that.
Yeah, me
me
too.
too. I can't wait to read it either.
Yeah. Your take on it reminds me of Diana Walsh Pasulka. Have you read her Encounters book? Like
No, I read
American Cosmic?
yeah, which
Yeah,
just as a title.
I know. I know. So her next book, Encounters, continues to bring along this idea and that you just described, but it's this idea that when people get proof oriented and they say, well, I don't believe that. In the world of materialistic science, you're saying, I don't believe that physically happened.
Right.
But what you're talking about is the world of non-material experience. So are you saying, I don't believe that experience happened for that person, so they're lying about their experience? Or are you, so because because the culture does not differentiate between scientific materialism and science,
Right.
and those are
Right.
very different,
Right. Which
right?
is really true for you.
It's true for everybody, but definitely true
Yeah.
for both of us. And
Yeah.
yeah. Because of
Well,
that
I mean,
lack of differentiation, then there's this lack of understanding of what it means to believe something.
but you have to deal with things that I don't have to. And, people ask me or warn me in advance, couldn't this ruin your career?
Yeah, all the time.
Well, my career is looking at medical biopsies or surgical resections from people. My hospital doesn't care what I think religiously or in the broader sense scientifically, as long as I'm making the right diagnoses. And, my clinical teams in liver transplant and liver disease, I was out last year for 6 months because I had a stroke, and they were like, please come back. I have a salary. I don't
Right,
have to apply for grant funding.
right,
I don't have to go ahead, try and ruin my career. The hospital's
right,
not going to fire me or try to silence me.
right. And I've been watching you, and I'm definitely on board with trying to get a job where I could just do a thing and then
Yeah,
have
yeah.
opinions on the side.
But it's really, I'm very lucky,
Yeah, it's wonderful.
Yeah, yeah.
I don't think Carmen knows about the interstitium, the organ that Neil discovered. And I think,
I was trying to, I remember reading news reports
Yeah, yeah.
about it
That went
because
viral.
yeah,
you know, being fascinated by it, not quite understanding it, not having enough time or the appropriate context to focus on it. But you know, I'm a very non-STEMmy person who reads a lot of STEMmy stuff. So
Mhm, mhm.
that's how I wander into these areas.
Well, so I mean, I'll explain interstitium to you. It's not that hard. And I'll say we're currently thinking, we meaning the world's anatomic establishment,
Right.
not just my team. It's not an organ, it's actually a system. It's a level up.
oh,
But that's a whole other thing.
so it's like a circulatory system.
Like a circulatory system, like a nervous system, it's a body-wide communication network.
Right.
And but actually, it's 4 times roughly the fluid volume of the cardiovascular system.
Mm.
So
Wow.
it's much larger. It's 25% of the fluid volume of the body. And
Faster
it's communicating
communication.
across. Hmm?
Faster communication.
Well, and it's communicating across all levels of scale. So there's electromagnetic piezoelectric effects in the collagen structures. There's molecular signaling. There's mechanical signaling across the fibrous network that defines it. There's movement of small molecules, large molecules, cells. So I think from a complexity theory standpoint, a lot of people are asking me, so how do these two things fit together? Let me back up and explain what this is. What my team showed, and we stumbled into it, when you look at collagen on a microscope slide, like the ones I just showed you, is this just audio or is it video?
Video too.
It's video.
I can actually show you.
Yeah.
I can display my microscope
Oh, please do
slides.
that.
Geek out.
Yes.
Yeah,
This
yeah.
is
Because there's
why
nothing
people watch
like,
it.
right.
Yeah. Now, do you have share screen access?
Yeah, I do.
Good.
Let me turn on the program that allows me to do this.
As long as there's no HIPAA information, we're good.
No, 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 no.
Yeah.
Yeah, yeah.
Yeah.
No,
HIPAA
this
police.
conversation
Exactly.
persuades me yet again that what we know about what quote unquote reality is, we still only know a small fraction of
Yeah.
what is eventually, I don't know when eventually ends,
Yeah,
is going to be knowable.
Yep.
yeah.
Yeah, there's so
I
much discovery to come.
I completely agree with you, obviously. So, oh, I know what I can use. Um, uh,
I like the purple sort of backdrop you have, Neil.
you call that purple?
I do. Do you call that gray?
Yes, I do.
I call it gray. I call it gray.
Hmm.
What's your,
It, it,
I
it,
mean,
it
I
has
wonder about,
Why I call that purple? You know, we have a gray maybe wall that I call purple here. And I think it's because I don't love gray, but I love purple. And so I just turn it into
I
purple.
mean, and there is a transition gray to lavender to purple.
Yeah.
I get
Yeah,
that.
I guess lavender is the better color. That better description. That was green.
So this is some pancreas, human pancreas. This is a normal human
Ooh.
pancreas. And
Looks
whatever
good.
yeah, isn't that nice?
Yeah.
So these are the glands that produce digestive enzymes. And the structure has all this pink staining collagen here. And so this collagen is the support network outside of cells all through the body. There are other molecules in there, but collagen is the most predominant one. And collagen has the property of being kind of stiff when you fix it and dehydrate the tissue. And so you see that there are these white spaces where there's no collagen. And I've been taught, and I have taught for decades, that these are cracks. The tissue, the collagen is tearing because it's so stiff when you cut a very thin slice to make a microscope slide. And so wherever you look in the body, there's collagen like that. Here are the ducts of the pancreas. And so what happens is these cells produce the enzymes, and we don't see it in this section, but they drain into tiny ducts, which lead to the bigger pancreatic duct, and that leads out into the small intestine, the duodenum, where they empty in to help digest all the food you eat. And the pancreas is hanging off there in order to do that. And up here, this is a section that actually has some small intestine attached to it. And so here's the lining of the small intestine with the villi. That's where food starts to get, the nutrients that from digested food start to be taken in. And you see that there's also this collagen throughout the wall of the bowel, and we see the same cracks. So it turned out, just by chance, friends of mine had this new endoscope where they use it to look down into the body through the mouth, into the esophagus, stomach, and they were in the pancreatic ducts and the bile ducts. And when they looked at it, it looked different than what we were seeing on the slides. And so they asked me to tell them what they were looking at. And because they were seeing, you inject this fluorescent dye into the tissue, and so you can see it using the tiny microscope at the end of the endoscope. And they were seeing these big fluid-filled spaces around the pancreatic duct. And you can see, whoops.
There we go.
There are no big fluid-filled spaces. Whoops. There's a branch of the duct, and there are no spaces here. It's just dense collagen with these fine little cracks in it because it's stiff.
And the thickness of the slide here is the same as the other. So it's not that somehow it's not cracking here.
No, it's all the same. It's all 4/1000ths of a millimeter thick. So it turns out, this was the first paper that went viral, that in the living tissue, it's open spaces. And when we dehydrate the tissue, when we take it out, fluid drains out of it, we further dehydrate it to mummify it so we can turn it into a piece of tissue on a slide that won't disintegrate. And what we thought were cracks were actually the remnants of the fluid-filled spaces.
They're like caves or caverns where the river
Caverns. It's sort of like a
flows through.
sponge. It's a little hard to
Like
describe
a,
three-dimensionally.
yes, right.
Yeah, and it's fluid-filled. It turns out the major molecule going through there, we didn't have this at the beginning. My companion in all this, Becky Wells, who's a biologist, bioengineer, physician down at University of Pennsylvania, we've been working on this, and here's the slide. We found out that the major molecule filling those spaces is something called hyaluronic acid, which men in our culture have no clue what that is. But my guess is every woman does, because the whole cosmetics industry says, put on hyaluronic acid to make take away your wrinkles and blah, blah, blah. Because hyaluronic acid fills all these fluid-filled spaces, and it has a high water holding capacity. And so, and as you age, you get less hyaluronic acid, so you have less water, so your skin wrinkles. But you can't put hyaluronic acid in there with cosmetics. But when we look at it and stain, in this case, brown, this is the same piece of tissue, same hunk of tissue, just cut a parallel slide. So here you can say, we got rid of the pink stain that made the collagen pink. We can see the lining of the duct now, just the nuclei staining blue. And all these pale areas, that's what was pink in the prior slide. And the spaces between them, which looked empty on that slide, are filled with hyaluronic acid. And you can see at low power that, in fact, it's everywhere. That's the interstitium. So staining for hyaluronic acid, we can map the anatomic structure of the interstitium. And what we've now been showing, some papers have already been published, more papers are on the way, is that wherever you have connective tissue in the body, there is no dense layer of collagen anywhere. It's always alternating collagen, hyaluronic acid, collagen, hyaluronic acid. And since there's collagen around every nerve and every blood vessel, veins and arteries, and they're all in continuity with each other, you never find an interruption in the hyaluronic acid staining into separate compartments. So that not only is an organ communicating with itself through this network, but it's also communicating with the rest of the body along all the blood vessels, along all the nerves, in fact, up into the central nervous system. And we're publishing organ by organ, showing how all of these map together.
So the question, Neil, the container of the interstitium is collagen?
I wouldn't say it's the container. I would say, well, I would say that there is, you could say it's sort of like the girdering.
Yeah. So it's like a scaffold.
Sort of a scaffold, but then that puts the collagen in the service of the interstitium.
Right.
And what we're coming to realize is that what people have traditionally called fascia,
Yeah.
and some people contain more things within that term, some people contain fewer things in that term. What we're now realizing is everywhere that there's collagen is a form of fascia.
Mm-hmm.
And wherever you have that, you have alternating fluid-filled spaces. They're co-equivalent. So it's really the fascia slash interstitium.
Mm-hmm.
And the new terminology that my team is working towards, and it's a group of very high-level anatomists. We're not talking like a local sort of thing. These are international level conversations we're having, is that there's a fascial system that is pervaded by the fascial interstitium. Interstitium literally means the in-between. The interstitium that has, it's not a new term. There's been classically recognized the interstitium between some cells.
Mm-hmm.
Not all cells, most cells are tight together so that there's no hyaluronic acid or spaces between them. But the main part is around every capillary. There has to be a space around the capillaries before you get to the cells through which nutrients can enter the tissue to encounter the cells, and through which waste products from the cells can get into the vascular system for elimination. So that's the interstitium classically. What my team is responsible for is, no, there's an even larger scale, and this may be, in fact, a fractal network. And these interstitial spaces are 10 to 20 times the size of the pericapillary ones. So they're much larger scale. And no one ever addressed the question of whether those pericapillary things are actually separate tiny little pockets.
Mm-hmm.
But what we're showing is it's all connected throughout the body.
So you could strip out everything but the interstitium in a human body, and you'd see a human body.
And we do this actually. It's called decellularization. And about 20 years ago, and I was involved in some of this because of the stem cell work, it became clear that you could digest all the cells out of an organ and then put new stem cells in, and they would repopulate and recreate the organ. And they were growing along the extracellular matrix, which is mostly collagen, but there are lots of other biomolecules. And you could reconstitute an organ. And the idea of this was you could take, for example, a pig liver, which is about the size of a human liver, decellularize it to get rid of all the pig cells, and then put the cells of a patient who needed a liver transplant into that, and it would repopulate and create a human liver made of cells of the person who's going to receive it. That's sort of the pie in the sky idea. This has actually been done with urinary bladders successfully.
It's a bit like 3D printing using the design as the interstitium, right?
But what's happening is the cells are interacting with each other like a complex system to self-organize around the structures, right?
Right. Yeah, so it's all about how complexity works. Neil, did you want to show any more slides, or should we take
No,
share
I'm sorry.
screen off?
We can take that.
I just want to see your
I have
face.
one comment.
Yeah.
And I'm reminded of when I was listening to your book, how you talk about the early microscopes discovered cells. And
Yeah,
so everybody concluded that we were sort of cellular systems,
right.
but that now more modern ways of observing led people
Mhm.
to understand we are fluid. And I thought that was interesting. And then that and this reminds me yet again, this is my comment of what I learned as a knowledge worker at CIA is
I
one of my
love, I would love to be, maybe I'll just lie and tell people that. I was a knowledge worker at the
well, yes, I'm going to
CIA.
use that as my intro now. I like it.
Yeah,
But what I learned, but big takeaway of many about kind of working, trying to develop knowledge, is that everything we know is a function of our tools for knowing.
yeah,
And
yeah,
every person, every generation makes the mistake of thinking that this set of tools that they have at the moment is like the final set of tools
right.
that's delivering wisdom, when in fact, you're always in a transition period from one set of tools to
Yeah,
the next set of
yeah,
tools.
yeah,
And I just wanted to
yeah.
share that.
Well, and you know, the endoscope, this new fancy
Exactly.
endoscope,
Yes. Is what
I
showed
would,
you.
I would, without them having that in their hands and paying attention to something novel and bringing it to me and saying, what is this? And
Right.
the fact is that other groups had seen these spaces and reported on them, but they were all endoscopists who weren't interested in the science. And they all just showed it and said, well, that's there.
Right.
And no one else was reading those papers except endoscopists, because why would any scientist be interested? They weren't. So it's already there in the literature.
Yeah.
And going back, people are like, since we published the first paper and it's accelerated since, people are like, well, so-and-so saw this in 1943, so-and-so. And in our first paper, there are publications where we found a handful where clearly people saw this,
Yeah.
but they had no context,
Right.
or no one noticed that they had said it because it didn't fit. So,
Neil, did you ever read Flatland?
oh yeah, sure. Yeah,
Yeah, right. One of the best, right?
yeah.
And so in Flatland, so first you live in this, let's get to the part where you live in this two-dimensional world, and a third dimensional being puts a pencil through the two-dimensional world, and everyone's scurrying around seeing a small point start to, because they're seeing a cross section, small point increase to a large point and then back to a small point. And they have stories about it, but they can't tell the correct story because they have no access to this third dimension. That feels like a story related to the interstitium.
Mhm.
And in the
Yeah.
sense that, I mean, I don't know where, I mean, we're coming close on time, and I
Oh,
feel like this ties together these ideas of the non-material and material. But do you think that the interstitium is interacting with sort of extra dimensional or beyond
mm.
3 or 4 dimensions?
You're not the first person to ask me. It's amazing to me how many people's instincts go there. And a lot of people who ask me are people who have finally developed sensory abilities because they're body workers, cranial sacral people, Rolfers, osteopaths, and they can
Exactly.
feel the fluid to some extent, maybe the energy fluctuations through it. And which now I appreciate as being real. My Rolfer, my own Rolfer would say, well, there's fluid in your fascia. I was like, no, there's not. I can show you in a slide. There's no fluid there. And we included fascia, musculoskeletal fascia, in our original paper for her. So it's people's instincts that this is the case. I don't know. I don't yet see what a mechanism would be, but sure. I'm certainly not going to say no. I think that's the kind of thing other people will have to figure out. But well, I'll tell you this. When I speak to people and through my own experiences with energy practices, whether we're talking about the chakras or acupoints and meridians, I think that the 3D structure of the interstitium, and we've proven that there is an electrical current generated by this collagen because of movement independent of the nervous system. But it's a very complex system, as you're seeing. Are the additive electromagnetic fields of all these complex structures, is that actually the biofield? Is that what chakras are? And I have my own instinct for how that, in fact, is likely through my own experiences of energy stuff. And in fact, I started doing Tai Chi because I wanted to explore that more, because it's clear to me that something about those movements and what's happening to the musculoskeletal fascias, so yeah, everything's connected. I mean, you could just as easily say, well, is there a relationship to your liver? Of course there's a relationship. How about that poster on your wall? Of course there's a relationship, because the quantum level, there's no distinction between the quantum level phenomena that create the poster and your body sitting next to it.
Right. It's just
Mine
that
over here.
I feel like the reason the intuition goes there is when you think about this thing that connects, it's always
Mhm.
sort of, when you look at the slide, you're always having to imagine it connecting and this other dimension
I
that you're
have
not
to,
looking.
right.
Yeah.
And partly what lets me see it so easily is that I spend my day, I talk about this in the book, I spend my day going from the everyday scale to the microscopic scale. I have no problems with that transition. Interstitium researchers who pushed back against ours, saying, you're not showing anything new. I couldn't explain to them, we're up a level of scale because it's fractal probably, and it looks the same no matter how close in you get. So it looked like what they were studying, but they were studying the spaces around the capillaries, and we're studying, I can show you the interstitium. You can see your dermis. It's visible with the naked eye. They could not make that leap, but I can, because I spend my day making that.
Yeah. The flipping of perspectives creates a mind that can do that habitually, which is really cool.
And I think that's where, again, my Zen practice has really conditioned my scientific practice. In Zen, partly what you're practicing is, where do you place your mind? Are we focusing on the relative or the absolute? What's the sound of one hand clapping? Well, there's no one answer to that. There are all ways of approaching that. And the moment you think you have it, you have to confront the fact that, no, you missed it, because there's always something excluded. Anytime you grasp onto any view, you're excluding some other things. And that's the whole middle section of the book, talking about complementarity, is about that. We have to stop talking.
No, yeah, no, well, not forever. Carmen, is there anything
I mean,
else? Or
Julia,
Neil, is there anything else you wanted to say and make sure you said? Or Carmen, you.
yeah.
Well, no, I mean, complexity, which we talked about in another conversation with someone else. Complexity theory is such a big part of my knowledge journey, because I read Mitch Waldrop's book
Yeah.
in the mid-90s, and I realized when I read it that all of the theories that were discussed in that book, the vocabulary of that book explained many things that I had seen in the 1980s at work that I had been unable to contextualize,
Right.
and therefore get people to understand what I saw, right? So
Right.
complexity theory really gives you, I think, at a kind of first level, a vocabulary and a set of principles that you can use to discuss and share your insights with other people. Because
Right.
if they don't understand those words, if you don't have words you can convey it with, they can't understand your insight.
Well, and in terms of why I was able to write this book, partly it's because I came in not as a complexity expert, and you can approach complexity through the high-level computational mathematical structures that, I can't even come up with the terms right now off the top of my head. And it's very jargon rich and it's very technical. And I don't have the math and computational skills to really get at that. But reading that book, the book by Roger Lewin called Complexity, the book by Stephen Johnson called Emergence 20 years
Yes.
ago, those were the books that were out there for popular
Yeah.
people. They didn't put it this way either, but I realized in reading them that there are 4 simple things that sort of contain everything. And then I reached out to people who are computational mathematicians and complexity theorists. I said, are these 4 things really the whole package? And they said, yeah. And then you're off and running. You can
And
analyze
they are,
any
and they are.
situation. Yeah.
What are the 4 things?
Um, That's chapter 3.
I know, but
Yeah, I know. I'm just, pitching. It's in the book. Numbers matter is number 1. So 25 ants makes a colony, 250 ants, 25,000. But the more you have and the greater diversity of interactions between them, the more complexity. So a village is not a city, is not a megalopolis, but the same mathematics and principles apply across all those scales.
And this wonderful quote, misattributed to Stalin, quantity has a quality all its own.
And who is it? Who is it actually?
I don't know. I mean, it most commonly attributed to Stalin,
Mhm.
but people suspect he didn't come up with it on his own,
Yeah,
right?
yeah, that doesn't sound like his. Yeah. The second rule is that negative feedback loops have to predominate. So a negative feedback loop is like how an air conditioner maintains temperature in a room between a homeostatic thing. It's not negative as in bad. It's negative as in if you go too high, it negatively turns off and the temperature goes down. Go too cold, or the other way around, gets too warm, etc.
It's like it's balance, the law of balance.
It's balance, it's homeostasis, it's keeping things, all living things. If you have a living system that's completely stable, that's a dead thing.
That has died.
All,
Yes.
all living systems oscillate. Now you can have positive feedback loops. Imagine a room in which the heater turns on, and the warmer the room gets, the higher the heater turns on. You can have that, but it can't predominate. If it predominates, you can get self-organization like tornadoes, hurricanes, cancer, but those will not adapt creatively the way complex living systems do. They'll explode and then collapse. Economic bubbles, cancer. But we know we have those when you have a fever because you're fighting off an infection. Your temperature goes up. That's a positive feedback loop. But then when you get rid to drive the metabolism of a revved up immune system. But then when you get rid of the infection, it has to come back down again. And that's where the negative feedback loop. So there have to be a balance of predominance of negative feedback.
In complex adaptive systems, but I think you made a key
Yeah.
point that there is complexity in other systems, but they're not complex adaptive systems. And what we're talking about is life.
Right. Yes. So the third rule is that things may appear top down, but in fact, they're bottom up. Everything that happens in a complex system is happening at the local level. In an ant colony, it's the pheromone signals between ants and their physical contact. There's no ant in the colony who's deciding, do we have enough food? Do we need to go to war with our neighboring colony? Where does the food line go? Where should we put the cemetery? It rises from local processing. Humans think in terms of hierarchies, but that's delusional. The fact is, it's what's called a holarchy. We're all part of a net. The person we think of who's the top of a hierarchical pyramid is usually the person who seems to have the most connectivity, but their connectivity is never truly global. There are always things they can't see. And this is why autocratic systems always fail eventually, because there's a part of the system they're not, that part of the book where I talk about authoritarian governments was changed a little bit in the Chinese edition that came out.
Oh, that's hilarious.
All they had to do, it turns out, was translate authoritarian as dictatorship. In China, they acknowledge they're authoritarian, but
they're not a dictatorship.
Oh, interesting.
So I'll accept that. And the fourth rule is the most interesting to me, the one that got me most excited when I first encountered it, is that there has to be a low-level randomness in the system. If there's too much randomness, you got ants wandering around, you got humans wandering around, there's no neighborhoods, there's no culture, there's no structure. But if there's too little randomness, then the structure that's established can't change if the environment changes. There's no way to explore new possibilities.
So it's not adaptive. That's the piece that
it can't be adaptive. Yeah. Right, exactly. So too much, you have no self-organization. Too little, there's no adaptation. So you need this narrow band of possibility. And so there are some implications to that. Number one is that around every present moment, the word Stuart Kauffman, one of the founders of complexity and a friend and mentor of mine, coined the term the adjacent possibles. Exactly. For every given moment, there's an array, not infinite, an array of adjacent possibles for what the next moment might be. And there's no way for us in this moment to know which of the adjacent possibles will be the next moment. So living things, whether it's our bodies, our lives, our culture, or the entire universe, as I go in my book, we're not machines. None of this is machine-like. The materialist view that the world can be modeled, thought of as machine-like systems, can't, because there's no predictability. But it's not infinite.
But our
Not all
society is
possibilities.
dominated by engineers these days, you know?
Right, right. Well, what are our dominant models? This is one of the problems we have with
Yes,
medicine.
of
What are our
course.
dominant models for, we talk about cellular engineering, biological engineering. We talk about cells as building blocks. These are things from 200 years ago where, yeah, machines seemed like a good metaphor for what a body is. But that was before we had computers and could do computational systems of changing over time and could conceive of chaos theory and complexity.
Before quantum
Those are the core
mechanics.
rules.
But it's still all very Newtonian.
Yeah,
Oh,
yeah,
and
yeah.
some institutions are more Newtonian than others.
Right. It's changing.
Governments are very Newtonian.
The fact that
Now, but there are some adjacent possibles.
right.
Yes, there are.
And I think the fact that my book remains afloat rather than sank like a stone is because there are people, and in my experience, some of them high-level academics, high-level scientists, high-level physicians, high-level economists who read it and go, oh yeah, this is a view worth looking at, is because things are changing. I think if I had published this book 20 years ago, no one would have seen it. I think that the books that were published on complexity 20 years ago, they're marvelous books. But I think that people weren't yet prepared to see what the implications were and could get excited the way they could see the implications of Glick's book on chaos and like, oh my God, this explains so much around the world I hadn't seen. They needed to absorb that before they could then absorb this. I don't know if my book, an ambition for my book is it accomplishes a similar sort of thing.
We'll see.
Yeah, we'll
Well, I wish that ambition to be fulfilled.
thank you.
Yeah.
And who knows, the wandering ant that isn't following the food line may be someone who wanders to listen to your podcast and hears something that we've said and turns it into this, culture, global changing phenomenon. You never know.
Yeah, we put out crumbs for that reason.
Yeah.